Welcome back. We're continuing to look at the CMS, the compact modular system router setup. Today is the turn of the sliding table, but first, here's a jingle. In the kit we get the sliding table itself, an aluminium construction, very sturdy, quite heavy. We get a rail that mounts onto the side of the CMS. Two clips that attach the rail to the CMS. A 10mm spanner that's used for loosening and slackening these wheels, the runners, that obviously adjusts how well the thing runs. We get a 4mm Allen key. We get some instructions. Notice the quality of the instruction book seems to be reducing the further I go in the project. This is just a very cheap paper copy, no nice glossy cover, but the same idea. You get a number of diagrams, not pull out this time, so you got to flick back into to reference them, and a multilingual instructions. It's pretty easy, so that's not really a problem having that sort of cheap production. Job one is we connect these little black clips to the table, and just down the base of the CMS table there's a small channel, and at the end there's large cutouts in the leg assembly. This nut here attaches into the channel. These clips at the end secure it into place on the leg assembly. Slide the nut in, slide it along, and click into position. And we do the same on this end. Slide the nut in, slide it along, and click into position. This has got two captured nuts inside it, and that takes these threaded bolts that are already attached to the rail. Exactly as we had in the extension table, we've got these black areas here, and they can adjust up and down, and that alters the height of the rail in relation to the device. The rail slots onto the V-groove like that. You can either have it in this position with the runoff to the end here, or we can have it in this position with the runoff to the end here. And I guess that depends on the type of work that you're going to be on. Unfortunately, you can't have it in that position, which would be a compromise of the two. So we're just going to put it in this position for now. It's very easy to adjust and change that position, so I don't think we lose much. So we line up these knobs here with the black pieces we've just put into place, somewhere around there, and then that just screws into place like that, and the same would happen on this one. We now need to adjust this rail in relationship to the table top. To raise it, we tighten down on these two nuts. To lower it, we loosen those two nuts. So we'll take a straight edge again, and we'll see how we're doing. So that one's low, and that one's low. So I'll loosen off the two nuts at the front. I'll come in with the 4mm Allen key, and I will tighten that down. And all that's doing is just pushing down on that black cam we saw before. And I'm going to get this a fraction higher than the table. Yep, that one's okay. Tighten this one down. Probably a bit too far, that one actually. That one's now okay. That's okay. Now tighten down the black knobs. And that's that done. That's that rail now adjusted. Obviously, if we move this along to the other position, we would need to adjust this one as well. But once they're done, they're done. So again, it's a one-shot deal. We've not got to keep messing around with that every time we take it in and out. The rail also comes with two end stops, these little black stops here. They fasten into position, loosen with a screwdriver, and you can see, very, very simple idea. Nut on one end, tighten the other end up, and a small rubber grommet to protect things. They position they dictate where this rail will run. So it positions where it stops. So there's a stop there, it won't be able to go past that. So we want to position it so this rail doesn't run off the end, so we want one stop here. We also don't want it to run off this end here, so we're going to put a stop on that place too. Easiest way I found, loosen the stop off, just pop the rail on. It simply goes onto this rail at the top, this top wheel on there, this bottom wheel collecting underneath there. Really simple. That's number one, number two, and slide that along until you get to the end of the travel, and that's about there, and then just go in with a screwdriver and fasten it down. Slide in the second one, adjust this there, and then fasten that one down as well. Don't want to do that just yet, because that actually locks the table into place. I want to talk to you, or just show you some things on the base here. This table has got some adjustments, and they're those here. There's one Allen key on this side, 4mm, and there's one Allen key, hope you can't quite see it there, on this side that's 4mm as well. And what you do is you undo these two notes here, just loosen them off, and then by tightening those up or tightening them down, you can change the position of this table in relation to the tabletop, and I mean the angle that sits there. So obviously we want this to be coplanar to this table here. Put the table into position, take our straight edge, and let's see how we are doing. Now at the moment, this end here is higher than this side here. So I want to take that down somewhat. So, with my 4mm, I undo this knot here. Oops. Bit tight to begin with, but that's okay. And the same on this one here. Just slacken off these two at the back. That's basically a pivot point, so we want to be able this to be able to pivot. So just loosen that off a little bit, not too much. And now, by rotating these, I can push down onto this, and that will start to adjust the angle. So if I want to take this one, I think it was down, we said, I undo that nut there. You can see that now has a little bit of movement inside it. That's at the outside of its movement now. And there's just basically a slot underneath that little screw there, and you're just sliding that across the slot. Tighten that one down. Repeat the same on this one here. And just try that again, bearing in mind we've not tightened up the fulcrum yet, so don't go heavy-handed on this. And that's a lot better. It's not perfect, so this end here is still slightly higher than this end here, but I've no more adjustment left underneath. So now I'm going to raise up this bar a little bit, so this then sits coplanar to that table. So I will just tighten down these two fulcrums at the back, loosening these knobs off because we know we need to. Drop the table on, and now I want to raise this up a little bit because that back piece was still ever so slightly high. So just wind that down. perfectly bang on. Wind that one down, and then tighten the black knobs. And give it a test. That's perfect. As we were adjusting that, you may have noticed this little black knob here at the side, and that's connecting to this little rubber nodule here. So if you didn't want the sliding action of that, we can now put that into place, lock it in down, and now that table is not going to slide anymore. And again, that could be useful to give us a bit of extra extension if we were working on a smaller panel. So it gives us some more flexibility and some options. Obviously, we want our sliding table to slide. Don't forget to put the other end stop back in. That's the table set up. That's a really nice smooth action. If you wanted that to be a bit looser, then you just simply loosen the wheels off underneath with the 10mm wrench, or spanner as we call it in the UK. The sliding table is not much use until you couple it with the protractor. Now this may look pretty familiar to you, and what comes in this kit is the clamp for holding it to the side of the table, the protractor itself, and the rip fence. The reason it looks familiar is because it's basically the same design as the one that came with the MFT3 accessory kit. The only difference is in this bar here, the one on this table is much longer. So in theory this one will work on this table, and it works pretty well on the router table because it is indeed smaller than the one that comes with the kit. This one gives you more reach overall on that bar, and that may be useful depending on the application that you're doing. This one, I think, is probably a better size for the type of work that we're going to be doing. This one fits in exactly the same way as the one on the MFT3 table does. You've got these two brackets here, you've got a knob here to tighten it on, and that simply slides on to the rail to a position round about there, doesn't really matter, and then that locks in. This clamp then rests into the V groove and clamps on like that, and then we clamping that down and tighten it off. This knob releases, you pull up on the indent guide, and that will now come around and set itself to 0 degrees. Now you could calibrate this to 0 in the same way that you did on the MFT table. It's pretty pointless because what's important is this in relationship to the fence. So it's easy to adjust the fence to be 90 degree with this because you move that fence an awful lot and it's never set. The one thing I've not been able to buy separately, which is why you go for this kit, is the actual rip fence. Standard T-slot, so we could probably make something if we really wanted to. And it fits on in two ways. It can slide in so we have a high fence, or it can slide in so we have a low fence. And again, that would depend on the material that we're working on. Once it's in place, that simply locks down. And now you can see I've basically got a cross-cut sled. So if I wanted to, I don't know, route something onto the end of this piece of timber, that gives me the support to do that. Now the next thing you need to think about is this has got to be set 90 degrees in relationship to that fence. If it's not, then we're going to be cutting skewed angles on the end. The easiest way to set this is by using a right angle. Normally we put a straight edge on that bearing, just lift it up a little bit, and then we bring the fences in to do that. It doesn't really matter whether the fences are in that position or whether they're square, as long as they're in line with that bearing. When we're using this side extension, it does matter. So I'm just going to bring that in, I'm going to bring it up here, and I'm going to hold the set square against the fence. And now I'm going to line the fence up so it's not only flush with the bearing, it's also flush with this area here. And when I lock that down, the fence is now at right angles to my rip guard. And it's that simple. And that's an adjustment we'd have to make every single time that we're using the fence. So it doesn't really matter if this is parallel now to the base, we know it's 90 degrees to this area here. So when I come in with my stock to make a cut on there, I know I'm going to be in the right place. I'm going to go ahead, I'll raise this piece up, just so it matches the profile that we cut, or more or less matches the profile we cut previously, which is about there. And let's go in and make a cut to see how this thing works. There we go. We have an end cut on this amazing profile that we've been creating over the last few videos. So that's it. That's the compact modular system. We've looked at the extensions, we've looked at the side table, we've set the router up, we've put it through its paces, and to be honest with you, it feels really, really good. It's nice to use, it's simple, it's Festool quality. And it wasn't really that hard to set up. It looks intimidating because of the amount of kit that arrives. The thing that I really, really dislike is, look at all these bits that I've now got. Because it's so configurable, there's lots of spare components coming with this. I've nowhere to store them. For the price of the kit, Festool, why did you not just put a Sustainer 2 inside there that we could then give all these things a home? Luckily, in our Sysport, we have spare Sustainer 2s, so one of those is now going to be dedicated to the collection of stuff, and you probably want to think about doing something similar. But it works well, it operates well, it's easy to set up, it's solid, it's substantial. That's good enough for me. See you next time.